And welcome to today's The Bridge Show. And guess what we have for you today? A huge thing about new recommended practices. I can't wait to get started, so let the show begin. But first of all, I'm not alone in the studio. I got Kenneth in the red chair. Welcome, Kenneth.
Thank you, Simen. I'm wearing the classic engineer outfit today, as you see.
I see you do, but you also, is it any secret code message embedded into your shirt?
Yes, I'm not really. I don't really remember the words right now, but I think it begins with something, maybe. Yeah.
Is that all?
Yeah.
I thought it was, some amazing new code in C++ that would astonish the audience.
Yeah, we could. It is actually its own language by itself. I won't say what the compiled program actually does.
Oh.
It's very interesting.
My goodness, is it benevolent? Will it hurt anybody? Or okay, so there's now a kind of, let's say, the challenge is on. Please go and program this into your computer and see what comes out.
Good luck.
Okay, that will obviously not help. But we're not here to talk about this, and welcome, of course, to our IP studio here in the basement of Bridge HQ on this marvelous Tuesday. Spring have arrived. We have great weather. It's sun. It's, the flowers are blooming. Have you been out in the sun lately?
No, of course not. I've been inside doing work and reading.
And you've been reading up to something we're going to talk about today, haven't you?
Yes. So today we're going to talk about an emerging new recommended practice.
Yes, we are. And that's also why we have a special guest live from Geneva in Switzerland. Welcome, Thomas Kernen. He is then one of the big and one of the absolute, system architects from NVIDIA. And Thomas, welcome to Oslo.
Thank you, thank you. It's nice to be here.
So before we start, is it springtime at your place as well?
Fortunately, it is. The flowers are blooming. There's still some snow on the mountains. But yes, spring is definitely here.
Oh, yes, I can't wait to get out in the sun. But before that, we are talking here about a new standards proposal that you have contributed in writing, haven't you?
Absolutely. So I actually chair the SMPTE Technology Committee 32NF, but I also am the chair of the drafting group for a very nicely named recommended practice called 2059-15, which, as its name does not tell you much about, is related to solve an ongoing problem that we have in the media industry and actually in the wider industry, which has got to do with how to reconcile information related to timing in a way that can be consumed by multiple systems and that is representative for users to understand the capabilities of their infrastructure.
Yeah, because right now, when people start fiddling about with PTP-enabled networks and bigger systems, that consists of many switch layers and switches themselves, they're kind of used to, in best case, they have a green light somewhere telling them that, yes, PTP is on.
So that's if they're lucky they even get the green light. I would say that in some cases that's even optional. The problem is, I think that people have underestimated, it being users or implementers, the importance of having a reliable timing infrastructure for the systems they want to build.
Yeah.
And just saying that it works or it doesn't work doesn't tell you much. So you're happy when it's green and you can go and sip your coffee and have a good day. But the truth is, as soon as something goes wrong, you need to understand what has gone wrong, why it's gone wrong, and you need to be able to correlate it to other events. And that's really why such work needs to be carried out.
Yeah, because it's very similar, Kenneth. Well, we'll go into details on 2059, but you know, one of the first applications that we did when we launched our 440 was to, of course, be able to display that we got good timing from, you know, either the boundary clock or the Grandmaster itself. And that's one of the core things on the 440, isn't it?
Yes, indeed, Simon. From the 440's perspective.
Yes.
So the challenge may then become, how do you know this information about all the devices in your network?
Exactly.
So knowing that your Grandmaster clock and your PTP leaders of the network is working at its best optimum capacity is one thing, but you would like to perhaps have a way of knowing that each of the end devices, the PTP followers, if you may, are actually working as they should. Yeah,
because one of the key things on the 440 is to look at the physical flows and then decide that, you know, the timing of the individual flows is okay. But as you say, it doesn't even take into consideration the end user devices. And you know, here, Thomas, that is particularly where your proposed standard comes into play, so that you can have a lot of metrics from them, all the systems that is in the path, like switches, routers, any kind of processing devices that's in the chain, and of course the end device itself.
So absolutely, it covers the entire chain, and it's got a lot of parameters in there. So when you open up the recommended practice, people might go, oh, why do I need 500 parameters? And it's not there to scare people to go, oh, I need 500 parameters to understand what time it is. It's to say we have different classes of devices, we have different capabilities. You need some devices, for example, a boundary clock, which may be reporting certain types of information which other devices don't. It's also based on the compute power of those devices. So for example, you know, a stage box connecting microphones might not need to have the same as a Grandmaster. And we wanted it to be complete. So it's not only about pure timing and saying, you know, give me my offset from master or my mean path delay, which tend to be the first things that people think about, other than the green light, of course. It's really got to do with saying, well, this works, but how is it working? And how does each device in the network think it's representing time and consuming time? So you can build trends and dashboards and historical data and correlate it. An event happened here, what did it do to other parts? Or you have a problem in your 2110 media flows. Can I correlate it to a timing event that occur? And again, for the specific devices such as Grandmasters, where we actually created a whole subset, people want to know about the GNSS, i.e. the GPS timing reference clock that they're going to be using. And, you know, how many satellites they have in view, how many constellations they're using. Or even you could look at it from a spoofing point of view, from a security point of view. Why is my timing source moving? Then maybe I'm being, you know, attacked, jammed, some sort of events going on. So the metrics that are provided in there is to allow people to go and be innovative and build models with that information. But in order to build the models, they need to have a common reference point. And that was the important thing about the object model that's been defined. It's the building block to allow the VB440 to bring in a new capability, or to allow a user to say, okay, this is important to me. This is how I want to measure it in commissioning, but this is how I want to measure it when I'm doing deployments. And this is how I measure it when I want to do troubleshooting. So I have a whole set of information I can use.
So it's pretty comprehensible, and it builds also around some maybe for broadcasters a bit unfamiliar kind of territory, because it builds upon the, in telecommunications terms, very well-known netconf you know, architecture.
Yes, absolutely. So About 15 years ago, the telecom industry decided that maybe SNMP was not the way of the future.
Whoa,
I believe
yes.
they decided that before. But, although people still want SNMP in 2021, the truth is, about 20 years ago, people already knew that it would not scale.
No.
And other models came out. So there was a lot of work that initiated from the telecom industry where they needed to be able to do network configuration, i.e. netconf, at scale and in distributed environments.
Yes.
And in correlation with that, they built a data model which is based on something called Yang. So a lot of people hear about Yang and netconf. The important thing in the model that we're talking about, it uses the Yang properties. It's defined based on Yang, but you can consume it in many different ways. You can consume it via netconf. You can use it via restconf. You could carry it over carrier pigeons, should they be fast enough and accurate enough to deliver the information you want. You could be using other interfaces, GNMI, which is usually used with another type of framework called OpenConfig. But the important thing is the object model.
Yeah.
And the fields that are defined in there, how they are consumed. We want to give the industry the liberty to go and do what is appropriate for them and for the users.
So it's, again, a very comprehensive standard. Even though it's very, very easy to see, the physical specification, and there's a lot of leeway in the individual parameters here. But again, I had a small bet with my colleague here on how soon we were going to mention REST, and it wasn't, of course, a long time at all. So that means that basically, how would you say, Kenneth, that implementing some of this, how much resources would you need to actually get some sense out of that?
Well, for the information model, the beauty of it, as Thomas says, is that you can implement the subset of the model that you have the resources for, or that goes for compute resources, but perhaps also for your, let's say, development team. What's the important, let's say, subsets you want to prioritize to get into your product first?
Yeah.
So you don't have to implement the entire
data
model.
You can just pick and choose, basically.
More or less.
Yeah.
Yes. But of course, to be useful for end user or operator, you sort of have to implement let's say a representative subset that will help them actually diagnose network.
Yeah, because that brings us up to the next thing, because it's all about correlation, and that's where it also becomes very interesting, that you don't need then only to focus on points of interest, but then to correlate, and now we're talking about some bigger types of abilities of usage for the 2059-15.
So yeah, the data analytics side, if you want, once you've got all the data from the different devices, you either consume them real time and you want your dashboard, or you actually want to do predictive models. You see degradation that is appearing or changes in value, maybe in a subset of your network, or branched off a given device, and you're like, there might be a correlation between these events, or you've gone through the upgrade of a firmware on a specific set of devices, and you see now something has changed. So you can start building these baseline models. You can start understanding this event or this outage was triggered by XYZ, because we can report back into history and understand when things occurred, how they occurred. And as I said before, all this timing infrastructure is there for one reason. It's to support the 2110 flows or other systems that need to consume the timing. So being able to do 2110 flows without a understanding of your underlying infrastructure means you're flying blind. It's like, I don't know, a pilot in an airplane which has switched off the instruments and is in the middle of a storm, and is just going to trust that he knows where he's going and he'll get there. A bit of assistance might be useful.
Yeah, that's very true. No, it's like, I've been there before, so we probably will arrive okay, even though there's a storm happening. So you're right.
But it might be a bumpy ride.
It might be a very bumpy ride and no landing in sight. But it's the exact same arguments that we've used for ages, that without visibility into how the flows actually work. And here is again a different method, but again a very valid method of looking at the timing information and looking at all the different devices. I would say this fits very, very well into the 440's ability to look at the flows themselves, and then if we had the more data from devices, it will then, kind of just increase the ability to understand things.
Might be.
Yeah. Oh, he's a bit apprehensive there. I think he sees that this has real dramatic consequences for bigger networks. But obviously getting more detailed information to and from devices like the 440 is very interesting, especially more debugging of GNSS data would be nice, because of course if something impacts the satellite, we have this famous story, that suddenly there's a rainstorm, you lose coverage from 6 satellites, maybe down to 5 satellites, which is fine. But then again, you get the satellite back, you're suddenly up to 6 satellites, and then, of course, the Grandmaster will fire up, update your clocks, everybody, and then you have a lot of resynchronization happen, and it will be a bit of a wiggle room until the system stabilizes again, and nobody is the wiser, because nobody actually understood what was happening.
Maybe not that extreme, I would think, but I get the story. But it is like everything. The object model is there to provide insight into information that can then become something of use and value, and not just bits and bytes that are being recorded. But it's actually a data trove to understand how the network is operating. There is no question about that. But it does not replace the fact that people need good grandmasters, well-cabled antennas for receiving the GNSS, GPS signals, that there are oscillators in there for holdovers. So
exactly.
None of this is a get-out-of-jail card.
No.
But what it does, it gives you that extra understanding and that extra comfort that we see many people need in the industry for very valid reasons. How does the system work?
Yeah.
How does it operate? I am commissioning a device in the lab, or more to the point, when we're doing interop events in the industry and we want to compare apples to apples in what is being reported, verified, and certified between the different implementations, these tools act as the lingua franca for us to be able to move forward.
Yeah. No, I totally get that, and I can foresee some lightweight netconf signaled objects that's possible then to just get basic rudimentary real-time information from. That could be useful in any case, from any kind of device standpoint, down to recording of constant data flows for then more analytics purposes, etc. So there's a width of capabilities. But it's very interesting that you guys base it around, of course, netconf, because that hasn't been any tradition in the broadcast industry so far, I say.
So we've actually based it around the Yang side of the Yang netconf discussion, because Yang is what defines. So yet another next generation is what Yang stands for, because as we all know, the only thing that is good is the next one, because it's brighter and shinier and so on. But more to the point, the Yang model has been well defined, specifically in the telecom industry, because that's where we said the roots came from, with the netconf as the transport and as the means to configure. And by the way, one thing I didn't point out is the 2059-15 model is designed as a monitoring tool, okay? So in theory, it's read-only, but we're not preventing any vendor or any implementation from actually allowing you to be able to take that information and use those fields also to configure a device, should the vendor in the implementation allow for it. So that's good.
That's very interesting. Well, life and man is no island. Time is obviously no such thing either. So I think it's time with some culture here. What do you think, Kenneth?
Culture?
Yes?
Sure, go for it.
Well, then I say that without further ado, I think that we'll put the cultural aspect in the hands of our mad musical genius. Here is Axel with his latest. And we are back. So how did you like that, Kenneth?
Amazing.
Okay, yeah, he's a huge classical fan, of course. What do you think, Thomas, of our mad musical genius's performance?
I always enjoy those. And they're highly entertaining, and I'm always wondering what's going to come next. So it's always a good teaser.
And well timed. Oh my goodness, that was a horrible joke. But we are talking about PTP's synchronization here, so why not? Thomas, I'm very, very grateful you could come and do some insight into this recommended proposal. What's next for it? When is the next milestone for the recommended practices now?
I have to say I'm happy you asked. So in non-traditional SMPTE work, we're doing this slightly different. And the reason is there is a new model in SMPTE in the standardization process called a public committee draft. Now, I'm not going to run you through all the loopholes of how we get from a draft to a standard, but traditionally it's always happened, I would say, within the technology committees. But what we've done for this and for most likely other documents in the future is it's actually been published as the draft, the current draft, on GitHub, for everybody and anybody to go and read and review and comment. And yes, we are really looking forward to having feedback from the user community, from the vendors and so on, so we can improve the model, make it as accurate, both in terms of definitions, but also in terms of usage models that can be possible. So that when we actually then finalize it, we take on board the inputs, we complete it, and we make it a better recommended practice than it would have been if it was just, let's say, the core team that worked on it within the SMPTE Technology Committee. So yes, this is my call. Please, please, please review. Please comment. It doesn't have to be detailed, but everything that users can think about is most welcomed.
Well, and I will say to the audience that is watching this now on this Tuesday, here is the URL. Please click into it. Go into the recommended practices 2059.15, read it, and please comment. Comment like crazy, because again, you'll help Thomas to finalize this. And this is open right now, right, Thomas?
It is. It has been open for a few months already, and it is still open. We're going to keep it open at least for a few more months. It is obviously, not something you're going to read in one go, and you need some pretty strong coffee to go with it, I would say. But it's worth your time should you want to run a good system and you're concerned about making the best out of future standards. And this is an offer from SMPTE to actually have a more open process and for people to contribute. So, take the opportunity and make the most of it.
Well, with that fine thought, I say a big thank you to you, Thomas. It's been a pleasure to have you live from Geneva in Switzerland again on the show, and I have a slight feeling you'll be back pretty soon.
So thank you for the invite. It's always a pleasure to be on the show, and yes, I look forward to the next opportunity to entertain the audience.
And of course, thank you very much, Kenneth, for joining. It's always very reassuring to have real, deep expertise on my side here on these pretty complex technologies, and especially the new technologies. We love new technologies, doesn't we?
We do.
We do. Yet another generation. Go Yang, I say. Absolutely, no kidding. Well, that's all for us from the IP studio in the basement of our HQ here in Oslo, Norway. Please, guys, enjoy the springtime and, of course, take care and see you next Tuesday.